April 20th, 2021, a toaster-sized gadget on Mars turned CO2 into breathable oxygen for the first time in history. Not in a lab, not a simulation, on the surface of an alien planet. NASA ran the experiment, the results are in, and it worked. But here's what no one's talking about. The same machine that breathed on Mars might change how we survive off Earth forever. Here's the reality. Mars wants you dead. Its atmosphere is 95% carbon dioxide, gas that suffocates you in seconds. Only a fraction of a percent is oxygen. You couldn't even light a match there, let alone take a single breath. And the pressure? 100 times thinner than Earth's. Step outside without a suit, your lungs collapse instantly. And that's not even the worst of it. Temperatures can drop to minus 80 Fahrenheit. Radiation blasts you constantly. And the dust storms, they swallow entire landscapes. So when people say, we'll live on Mars, you've got to ask, how do we breathe? How do we stay alive when even the air is trying to kill us? Because until now, all we could do was bring our air with us and hope it didn't run out. Survival tech level 1, bring your own air. Hope it lasts. It's the oldest survival trick there is. Ancient legend says Alexander the Great lowered himself into the sea using a giant glass barrel. No backup air, no filters, just a bubble of precious atmosphere. He supposedly brought a chicken to tell time, a dog to swim to the surface in case of emergency, and, get this, a cat to clean the air. Now I'm pretty sure the science wasn't exactly solid on that one, but the idea was right. When we first ventured into the oceans, into submarines, into space, we packed our air like cargo, carried it on our backs, and it worked until it didn't. On today's submarines, on the International Space Station, they still carry backup oxygen tanks, pressurized canisters, chemical packs that burn sodium chlorate at 600 degrees Celsius to release emergency air. But those tanks, they leak, they degrade, and eventually, you run out. And that's the flaw. Every system we've built so far is tied to Earth. We bring the air with us, but if something breaks or time runs out, we're done. You can't call Amazon for a resupply rocket. So yes, bringing your own air works, but it's not sustainable, not for a weekend trip to Mars, not for building a permanent colony. If we ever want to stay on Mars, we need something better. And that's where NASA's little gold box changed the game forever. But before that, let's talk about level 2. So after bring it with you comes level 2. Take it, use it, then clean it, use it again. This is how we've kept astronauts alive on the International Space Station for over 20 years. Not by shipping oxygen from Earth every month, but by recycling everything. And I mean everything. Water, 98% of it is reclaimed from sweat, from breath, and from pee. Yes, NASA made a machine that turns urine into clean drinking water. They even have a saying up there. Yesterday's coffee is tomorrow's coffee. But water isn't just for drinking, it's also your air supply. Using electrolysis, the ISS splits H2O into hydrogen and oxygen. The oxygen gets released into the cabin so astronauts can breathe. The hydrogen, that's where things get tricky. You can't just dump hydrogen into space, it's explosive. And losing hydrogen means losing part of your water molecules forever. So NASA uses something called the Sabatier reactor. It takes hydrogen and mixes it with waste CO2 from exhaled air. What you get is water and methane. The water goes back into the system. The methane, vented into space. Useless for now. On Earth, we care about molecules. Oxygen, hydrogen, water. In space, what matters is atoms. You need to keep every atom of carbon, hydrogen, and oxygen inside your loop. Because once you lose atoms, you lose life. And the ISS has another trick. Solid fuel oxygen generators, nicknamed candles. These canisters, when heated to 600 degrees Celsius, release bursts of oxygen. But once used, they're gone. Single use. They're a last resort and not exactly safe. In 1997, one of these candles exploded aboard the Mir space station, filling the module with flame and smoke. The crew couldn't reach one of their escape pods. Luckily, they survived, but that day proved something. Recycling systems are not foolproof. They degrade, they burn, they break. The truth. Even these advanced systems, recycling water, reusing oxygen, still leak. No matter how good the filters, you'll always lose a little here, a little there. And once enough atoms are lost, the system collapses. That's why ISS missions need occasional resupply. That's why even level 2 is a temporary fix, and it can't work on Mars, at least not by itself, because Mars isn't just farther away, months away. If something breaks, you don't get help, you die. So, what if we didn't bring the air with us? What if we didn't just recycle it? What if we made it there, from scratch, using only what Mars gives us? In 2021, strapped onto NASA's Perseverance rover, a gold-plated box the size of a car battery landed quietly on the surface of Mars. Its name, MOXIE, the Mars Oxygen In Situ Resource Utilization Experiment. Not a catchy acronym, but what it did? World-changing. For the first time in history, a human-made device made oxygen on another world, not carried from Earth, not recycled in orbit, created on the red planet from its toxic atmosphere, and that is where everything changes. MOXIE didn't just suck in Martian air, it used solid oxide electrolysis, a super technical term for a process that's pretty genius. Here's how it works. First, MOXIE pulls in CO2 from the Martian atmosphere, tons of it, then it compresses it, pressurizes it, and guess what? It doesn't stop there. MOXIE then sends that gas through a high temperature oven, 800 degrees Celsius hot. Why? To break the carbon dioxide apart, break the bonds between carbon and oxygen. The machine was only supposed to run a few times, but it lasted over 2 years, and what it proved might just change how we live in space, forever. Here's the catch, MOXIE wasn't perfect. It's not magic, it's a struggle to make oxygen in an atmosphere that doesn't want to cooperate. The challenge? CO2 is a stable molecule. It doesn't break apart easily. You need a lot of energy to separate those oxygen atoms from the carbon. MOXIE works incredibly hard to get just a few grams of oxygen, but sometimes it hits a wall. After a while, if you push MOXIE too far, the system clogs. The carbon bonds so tightly with the device, it could destroy it. This is called coking, a deadly buildup of carbon inside MOXIE's filters. When that happens, the whole experiment fails. And even with this huge challenge, MOXIE kept going. It worked when dust storms rolled in. It powered through freezing Martian nights, even during the wildest temperature swings. MOXIE was designed for short bursts, run it for a little bit, turn it off. But it just kept working. And the best part? It proved that we can make oxygen on Mars. Now, imagine if MOXIE wasn't just a small experiment. What if we could scale it without the energy nightmares? What if the answer was right in front of us, hidden in the cold Martian air? It's called plasma technology, and it might just be the breakthrough we've been waiting for. Instead of using tons of energy to heat CO2 to 800 degrees Celsius, what if we vibrate it apart instead? That's right, vibrate it. By introducing plasma, a state of matter where gas becomes charged with energy, you can knock the oxygen atoms loose, not with heat, but with electrical energy. The Martian atmosphere is already close to the perfect environment for plasma technology. Why? Because plasma works best at low pressures, and Mars has almost no pressure at all. That's the twist. Mars's thin air makes plasma technology more efficient than it could ever be on Earth. Here's how it works. When you pass an electric current through Martian air, you excite the CO2 molecules. It's like shaking a soda can until it pops. The vibrations in the molecules get so strong, they just explode into their parts, carbon monoxide and oxygen. The best part? This process uses only a fraction of the energy needed by MOXIE, and the results? 10 times more efficient than MOXIE's electrolysis. It could make oxygen continuously, using less power. This isn't just theory. On Earth, scientists are experimenting with low-temperature plasma to combat climate change. But on Mars, this could be the key to making life sustainable day after day. And the best part? It's ready for the next step. If we can develop this technology further, Mars could start breathing, all on its own. So, let's zoom out a bit. MOXIE was the first baby step, but it's MOXIE 2.0 and plasma tech that will bring the dream of Mars colonies to life. Think about it. What's it gonna take to make Mars our second home? It's not just about oxygen, It's about water, it's about fuel, it's about building a sustainable system that doesn't need constant resupply from Earth, and it all starts with resources already on Mars, the very thing Moxie and Plasma Tech unlock. Moxie showed us the proof of concept. We can make oxygen from nothing, just the air we're given. Now, let's scale it. Let's turn CO2 into fuel. Turn Mars's frozen water into drinking water, because once you've got oxygen and water, you've got everything you need to survive. Imagine creating a self-sustaining habitat with everything recycled: water from Martian ice, oxygen from CO2, and energy from the sun. Building your home out of Martian resources, living off the land, just like we've always wanted to do. In fact, NASA is already planning for this future. They're already designing MOXIE 2.0, bigger, more powerful, and ready to support a colony of astronauts, or perhaps permanent settlers. Mars won't just be a place to visit, it will be a place to live. And as we head into the future, Moxie and plasma technology are just the beginning. In just a few years, humans will set foot on Mars. They'll breathe the air, grow the crops, and eventually, they'll call it home. We might not have all the answers yet, but with Moxie, we've learned how to turn nothing into something. And that's the magic of space exploration. Before you go, I need to say something. This channel is brand new, and we're not monetized yet. Every video you see here, it's made with a lot of time, effort, and passion. I pour everything I've got into making these videos, crafting them, researching them, and making sure they keep you coming back for more. So, if you've enjoyed what you've watched today, please take a second to hit that subscribe button. It's free, and it helps me stay motivated to keep bringing you content like this. Your support means the world to me, and it keeps the wheels turning. Thank you for being part of this journey. I'll see you in the next one.